Hello, welcome back. Today, let's try another Leetcode problem. 1231, divide calculate. So this is basically a binary search problem. So let's just go to the problem. So we are giving an array of sweetness. So this means it is a chocolate bar. Yeah, but at the different places, it has the different sweetness. So for example, the first place is 1 sweetness, and the second place is 2, and the last place is 9. Yeah, but we want to divide the sweetness. We want to divide this sweetness array, divide the chocolate into several parts. Yeah, so here we are giving a k equal to 5. This means we are going to give k friends, but plus ourselves, plus myself, it is 6. So this is y. So for me, myself, I'm going to take the least sweetness. For example, I'm going to take 1, 2, 3 because 1, 2, 3 is 6. And then it will be divided like 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in total, there are 6 parts because 1, 2, 3, 4, 5, and 6. Yeah, but what I gonna choose? For me, I will only choose the least sweetness. It is the sum of 1, 2, 3. It is 6. Yeah, and then I will give this chocolate to my friends. Yeah, but for the result, it should be return the least. Yeah, the minimum number. So it is 6. For example, I can also divide it like this. I will choose a 1, and others maybe 2, 3, 4, and others, but I can divide it to 5. My other 5 friends, but I will choose 1. But 1 is not the maximum. Yeah, so here means we want to divide this chocolate, but we want to have the maximum of the minimum. Yeah, so means we want to find the maximum total sweetness of the pieces. So this is also can be a solution, but this is not the maximum. What about we choose 1, 2, 3? So after that, so this is the maximum. So this is what the question asked us to return. For example, this one, k equals to 8, and there's only one way to cut the bar into 9 pieces. Yeah, because inside the array we have only 1, 2, 3, 4, 5, 6, 7, 8, 9. We have only 9 numbers. How can we cut? We can only cut to 9 pieces. Yeah, and then each one of them only have 1. So for me, I only choose the smallest number. It is 1 because I cannot choose a bigger number. If I choose 1, 2, it's not possible. Yeah, because I have to divide it to 9 pieces. I will take 1, and my friends will take 8 pieces. Yeah, so this is basically the problem. So for solving this kind of a problem, if we are giving an array, so it is a 10 to the power of 4, it is okay. The sweetness is a maximum 10 to the power of 5. Yeah, for such problem, we normally use a guess. How can we guess? We normally guess a number. If that is okay, we're gonna guess another number. But how can we guess quickly? We can use a binary search to guess. For example, I'm going to guess a number 6 to check if that is possible. So I will use the brute force to check 1, 2, 3 is 6. So and then I will choose for 5, 6, 7, 8, 9. Oh, it is a possible solution. So yeah, 6 will be one of my possible solutions. Can I choose 7? Oh, I cannot, because if I choose 7, maybe 1, 2, 3, 4, and 5, 6, 7, 8, 9. So that is not possible. Yeah, that in that way, the minimum is still 5. It's not 7. Yeah, so in this way, this is why we're going to use the binary search plus the brute force to solve the problem. Yeah. Now let me go to my template to solve the problem. So for this one, normally I'm gonna use a check. So the check function is just like a guess. If I guess a threshold to check if that is okay. Yeah, and then I will use the k. So here I'm gonna just put a pass because I will define the functions later. I just want to write the binary search first. So for the binary search, normally we should choose 2 numbers, the minimum and the maximum. Let's check what is the minimum. Yeah, so the minimum can be, let's go to the L and R. Yeah, so the minimum, what can be the minimum number? So the minimum can be the minimum of all those numbers. Yeah, maybe 1. So for example, that is 1. So can the minimum be 0? Yeah, It can also be 0. Why? Because if this k is like 100, yeah, the array's length is only like this one, it is 9. We cannot distribute it to 100 friends, so that is should be 0. There's no way. Yeah. So this is why the minimum should be 0. So what about the maximum? Currently, I will give a maximum of the sum of the sweetness. Yeah. But it can be even less. But currently, yeah, it's also safe if I give a sum of sweetness, it means the total. Yeah. It can be the maximum. For example, I just need k equals to 0. I don't need to give any one of my friends, so I will take sum of them. I will take the total chocolate bar. So what is the value? It is the sum of it. But let's check the k. So k is less than or equal to 0. It means our guess is right. Yeah. Now let's go to define another variable, result. So I'm going to give another variable, result, because for my binary search function, for my binary search, I'm going to return a result. Now let's go to the binary search. So for L and less than or equal to R, we're gonna calculate the M should equal to L plus R minus L divided by 2. And then I'm going to check. So in the check function, I'm going to give a M and then with K. Yeah, if this is possible, so what I'm gonna do, so the result should equal to M because M is a possible value. And then I'm going to update my pointers, L pointer and R pointer. So for example, this result equals to M. So M is a possible value. For example, M is, in this example, maybe M is 1. So M equals to 1, it is possible to distribute to 5 friends. Yeah, and also for me, I will take the least sweetness. But can we have a bigger value? Yes, we can. What about we have a bigger value? So it means L should equal to M plus 1. Otherwise, so the R pointer should equal to M minus 1. This means if the check MK equals to false, so if this is false, this means this number is not possible. For example, if the this number is 10, 10 is not possible. So what about we try a smaller number? Maybe we try 8 or 6. Yeah, if we try 6, then we get the final result. So this is basically our binary search. So finally, we're gonna return the result. So here, we need to write the check function. So for the check function, we're gonna define 3 variables. So I is the index of the array, and then I'm going to use a count, and then I'm going to use a total. Yeah, because I'm going to use this total variable to check if that is more than the threshold. Yeah. So for the I variable, it should be equal to 0 because I'm going to count from the index 0. And for the count, it will start from the 0. And the total will also be 0. Yeah. Because if I'm going to count the next value, so the total will be set to 0 again. Yeah. So here is from the definition of these 3 variables. Now I'm going to loop through the sweetness. So for I s, let me just use I. For I in range less of sweetness. So we are going to loop through the array. Now, what we're gonna do for our total variable, so the plus the sweetness I. Yeah, so for this is total. For example, for the first one, total will plus this one, and then plus 2 and plus 3. So this currently we have a total. So what we're gonna do, we just need to check this total. So if this total is more than or equal to the threshold, what are we gonna do? Yeah, for example, if this 1 plus 2 plus 3 is more than or equal to 6, yeah, what are we gonna do? We're gonna set this total to 0. Yeah, because we are going to count for the next 4 and 5, so the total will be 0. So what about the count? So the count should be +1 because we find one part, one piece. Yeah, so this is okay. We find one piece. Yeah. Now we are going to go to the next. So the count should +1 and yeah, but if it is more than, but normally for this yeah, let me use a while loop for this one. I think the for loop is yeah, let me check if this for loop also works. So for this yeah, because I set a I variable, so I would rather use a while loop to solve the problem. So while I less than the length of the sweetness. Yeah, I will not use for because I is more clear for such kind of the problem. So for example, the I less than the length of the sweetness, and here we're gonna use the total plus the sweetness. But out of the if, I'm going to plus the I by 1. So I plus 2, 2 plus 2, 3, and we have a 6. So 6 is more than equal to 6. The total will be set to 0 and count by 1. Yeah, and then I'm going to 4 and 5 to count again. Yeah, so this is basically the entire code for this check function. So for the finally, I'm going to return if this count, if my count is more than and equal to how many parts, it is k plus 1, because I will give k to my friend and I will keep 1 by myself. So this is basically the entire function for this check and this binary search. Now let me run it to check if this logic is right. I believe, yeah, it is right. I think so. Yeah, basically, it is a brute force plus binary search. For such problem, normally we should think of the binary search first, and then we're going to use the brute force to check if our guess is right or not. Yeah, as you can see, that the speed is not so fast. It is just 6%. It means something influenced our speed. Yeah, now let's just optimize a little bit, because what about the maximum? The maximum is the sum of the sweetness array, but the maximum can even be smaller. Yeah, because for me, I will take the minimum. So what about I take the average of the sweetness array? So I will take an average. So what is the average? It is divided by k plus 1. Now let me just run it to check if we can increase the speed. Now you can see it increased a little bit, but it's not so fast. Yeah, but it is still okay. Yeah, it's like 15%. Yeah, if you think a better solution, please make a comment. Thank you. If you think this is helpful, please like and subscribe. I will upload more Leetcode problem like this. See you next time.